In this video, we're going to look at everything that you need to know for Cambridge AS Level Mathematics 9709, Probability and Statistics 1, Discrete Random Variables. Let's start with basic probability and distribution tables. A probability distribution table shows the respective probabilities for discrete random variables. Please don't let the phrase discrete random variables scare or confuse you. All this means is that the values are not grouped together. To draw a distribution table, you need two rows. The first row is for the variables x, and the second row is for the respective probabilities. So, to draw a table, we need two rows. In the top row, in our first column, we write x, and in the second row, we say the probability that x is equal to x. So it will look like that. In some cases, the random variables will be given to you, and in other cases, you may have to calculate them. Just remember that the sum of the probabilities in a table is always equal to 1, and you can use this to make sure that your probabilities are correct, or if you need to find an unknown. Now let's look at the estimated mean. To find the mean from a probability distribution table, we use the formula, the estimated mean is equal to sigma xp. Here, x is the random variable, and p is the respective probability. In other words, to find the mean, all you need to do is multiply the random variable by its respective probability, and then you add all of those values together. Now we can look at variance and standard deviation. To find the variance from a probability distribution table, we say that variance is equal to sigma x squared p minus sigma xp squared, where x is the random variable and p is the respective probability. Now, this formula may look complicated, but it is actually quite simple. We find variance in a very similar way as we have in previous sections. Sigma x squared p over here is the sum of the squared variable multiplied by its respective probability, and sigma xp squared is the sum of xp squared. The standard deviation is the square root of the variance. So to find standard deviation, all you need to do is square root your variance. Let's look at a basic example. The spinner below consists of 5 sides, numbered 3, 3, 5, 7, and 7 respectively. Determine the respective probabilities and the variance. Let's start with our distribution table. In the first row, we know the first column is x. And then we follow this by the values that we need to consider. We have 3, 5, and 7. So I can say 3, 5, and 7. In the second row, we need the probabilities. So we can say the probability that x is equal to x. The spinner has 5 sides. We have 2 3s. So the probability of 3 is 2 over 5. There is 1 5. The probability is 1 over 5. We have 2 7s. The probability is 2 over 5. We can tidy this up like this. Now we need to find the variance. So let's make some space. To find the variance, we use the equation. We say variance is equal to sigma x squared p minus sigma xp squared. Let's start with sigma x squared p. To find this, we need to square our x values. So for the first value, we have 3. 3 squared is 9. So we say 9 multiplied by its probability, 2 over 5, plus, then we have 5. 5 squared is 25, multiplied by its probability, 1 over 5, plus, we have 7, so we can say 7 squared, which is 49, multiplied by its probability, 2 over 5. And you can put this straight into your calculator. So we can say 9 multiplied by 2 over 5 plus 25 multiplied by 1 over 5 plus 49 multiplied by 2 over 5 is equal to 141 over 5. Put an answer is 141 over 5. But I still need sigma xp squared. So let's find sigma xp. All we need to do is multiply our x terms by the respective probabilities. So I have 3 multiplied by 2 over 5 plus 5 multiplied by 1 over 5 plus 7 multiplied by 2 over 5. Take my calculator. 3 multiplied by 2 over 5 plus 5 multiplied by 1 over 5 plus 7 multiplied by 2 over 5 is equal to 5. Sigma xp is 5. Therefore, in order to find sigma xp squared, we simply square 5 and we get 25. Now, to find the variance, I can say the variance is equal to sigma x squared p, which I know is 141 over 5, minus sigma xp squared, 25. Take my calculator. 141 over 5 minus 25 is equal to 16 over 5. This is my variance. Let's do another example. 2 tetrahedral dice, each with faces labeled 1, 2, 3, and 4, are thrown, and the random variable x represents the sum of the numbers shown on the dice. Find the probability distribution of x and determine the probability that any throw of the dice results in a value of x, which is an odd number. Here the random variable x is the sum of the 2 dice. Don't let the word tetrahedral scare you. Cambridge likes to use big words. All this means is that the dice has 4 faces instead of the usual 6. The important thing here is that the random variable is not the number on the face of the dice, but the sum of the numbers on the 2 faces the dice lands on. To find x, we need to look at all the possible sums. And this sounds like a lot of work, but it is actually quite easy when you use a table. So we know that each dice is labeled with faces 1, 2, 3, and 4. So let's say faces on dice 1 and the faces on dice 2. Now all we need to do is add these values together. 1 and 1 gives me 2, 1 and 2 gives me 3, 1 and 3 gives me 4, 1 and 4 gives me 5. 2 and 1 gives me 3, 2 and 2 is 4, then we have 5 and 6. 3 and 1 is 4, then we have 5, 6 and 7. And finally for our last row, 4 and 1 is 5, 4 and 2 is 6, we have 7 and 8. These are our values for x. I have 4 values in a row, I have 4 rows, so I have a total of 16 values. So I can make a note up here that n is equal to 16. In my table, I have 2's, 3, 4, 5, 6, 7, and 8. These are all my possible values for x. So I can make some space and I can start drawing my distribution table. Let's start with the top row. In the first column, I always have x. Now I can fill in my values for x. 2, 3, 4, 5, 6, 7, and 8. Now I'm going to use my table that I've just drawn to find the respective probabilities. Remember, in the second row of my distribution table, I say the probability of x is equal to x. In this table, I have one value of 2 out of a total of 16. So over here, I can say the probability of 2 is 1 over 16. When filling in the probabilities, you do not need to leave your fractions in simplest form. You can leave them all with the same denominator, as it makes this easier to add if you need to do calculations. So let's look for probability of 3. I have 1, 2 3s. So the probability of 3 is 2 over 16. Let's look for 4. 1, 2, 3. Probability of 4, 3 over 16. Look for 5s. 1, 2, and 3. And 4 up here. Probability of 5 is 4 over 16. Let's look for 6. 1, 2, 3. Let's fill in this. Probability of 6, 3 over 16. Almost done. We have 2 7s. So the probability of 7 is 2 over 16. And finally, we have 1 8. So the probability of 8 has to be 1 over 16. And now I can tidy up my table. The question says, find the probability distribution of x and determine the probability that any throw of the dice results in a value of x which is an odd number. In our table, our odd numbers are 3, 5, and 7. If x is an odd number, it could be 3, or 5, or 7. When we have one event or another, we need to add the respective probabilities together. So I can say the probability that x is odd is equal to probability that x is 3, 2 over 16, plus probability that x is 5, 4 over 16, plus probability that x is 7, 2 over 16. All of my fractions have the same denominator, so it makes this easier to add. 2 plus 4 is 6, plus 2 is 8. I get 8 over 16. Let's simplify, and we get an answer of 1 over 2. Now I'd like to look at probability distribution tables and unknown variables. You will never be asked to find the unknown value of a random variable x, but you may be asked to find the value of a given probability. Remember that the sum of the probabilities in a distribution table is always equal to 1, and you can use this to create an equation to solve for an unknown. If you are asked to find two unknown variables, use simultaneous equations. In most cases in your exam, you'll be given the estimated mean, and you can use this to create a second equation. Let's look at an example. A red spinner has 4 sides labeled 1, 2, 3, 4. When the spinner is spun, the score is the number on the side on which it lands. the random variable x, denotes the score. The probability distribution table for x is given below. Show that p is equal to 0,12. Now we know that if we add all of these probabilities together, we get a sum of 1. And we can use this to create an equation. I can say that 0,28 plus p plus 2p plus 3p is equal to 1. And now I can solve for p. I have 0,28. Let's leave this over here for now. P plus 2p plus 3p gives me 6p. And this is equal to 1. To get our p term by itself, let's subtract 0,28 from both sides. And I see that 6p is equal to 1 minus 0,28, which is equal to 0,72. Divide both sides by 6. And I've now proven that p is equal to 0,12. Let's do another example. A competitor in a throwing event has 3 attempts to throw a ball as far as possible. The random variable x denotes the number of throws that exceed 30 meters. The probability distribution table for x is shown below. Given that ex is equal to 1,1, find the value of p and the value of r. Let's start with the basic equation. We know that if we add these values together, we will get a sum of 1. So I can say 0,4 plus p plus r plus 0,15 is equal to 1. Now I can tidy this up. I have p plus r plus 0,55 is equal to 1. I'm going to leave this equation as it is for now. The question tells us that ex, the estimated mean, is equal to 1,1. To find the estimated mean, we say sigma x p. We take every value of x, multiply it by its respective probability, and then add these values together. 0 multiplied by 0,4 is still 0. We don't need to use this. 1 multiplied by p gives me p. 2 multiplied by r is 2r, so I can say plus 2r. 3 multiplied by 0,15 gives me 0,45. And the question tells me that this is equal to 1,1. Now in both equations, p is without a coefficient. So let's make p the subject in both. Let's leave p where it is equal to 1,1 minus 0,45 gives me 0,65. Move 2r and I get minus 2r. On the left, let's leave p where it is. 1 minus 0,55 gives me 0,45. Move r, I can say minus r. Now p over here is equal to p on this side, which means our equations are equal. And we can use these to find the value of r. So I'm going to say 0,45 minus r is equal to 0,65 minus 2r. Let's move our r terms to the left. Negative r plus 2r is equal to 0,65 minus 0,45. Negative r plus 2r leaves me with r, into r is equal to 0,65 minus 0,45, which gives me 0,2. And now I can substitute 0,2 into my r value in either equation to solve for p. So let's make some space. Over here, r is without a coefficient. So I'm going to substitute 0,2 in here. And I can say p is equal to 0,45 minus 0,2 is equal to 0,25. This is my value for P. Now I'd like to move on to probability distribution tables with K. You may be given random variables and an equation in terms of K, such as the probability that x is equal to x is equal to kx squared. To tackle questions like this, start by substituting each variable into the equation and determine an answer in terms of K. These are your respective probabilities. The sum of the probabilities will always be equal to 1, so use this equation to solve for K. Then you can substitute this value back into K for each probability. So let's look at an example. Becky sometimes works in an office and sometimes works at home. The random variable x denotes the number of days that she works at home in any given week. It is given that the probability that x is equal to kx multiplied by x plus 1, where k is a constant, and x is equal to 1, 2, 3, or 4 only. Draw up a probability distribution table for x, giving the probabilities as numerical fractions. Now, before we can draw up a table, we need a value of k. And the first thing we're going to do is we're going to substitute our given x values into x in this equation. So I'm going to say probability that x is equal to 1 is equal to, and now I substitute 1 into x. We get k multiplied by 1 multiplied by 1 plus 1. 1 plus 1 is 2, so I get 2k. Let's substitute 2 into x. Probability that x is 2 is equal to k multiplied by 2 multiplied by 2 plus 1. 2 plus 1 is 3, multiplied by 2 gives me 6, so I get 6k. Let's find the probability when x is 3. X equals 3 is equal to k multiplied by 3 multiplied by 3 plus 1. 3 plus 1 is 4, multiplied by 3 gives me 12, it becomes 12k. Probability that x is 4 is equal to k multiplied by 4 multiplied by 4 plus 1. 4 plus 1 is 5, multiplied by 4 gives me 20. So I have 20k. These are the respective probabilities. And we know that when working with distribution, if we add all of our probabilities together, we get a total of 1. So I can say 2k plus 6k plus 12k plus 20k is equal to 1. Let's add our k terms. So I can say 2 plus 6 plus 12 plus 20 is equal to 40. So 40k is equal to 1. This means that k has to be equal to 1 over 40. And now I can substitute 1 over 40 into my k values up here. 2 multiplied by 1 over 40 gives me 2 over 40. 6 multiplied by k, I'm going to put this over here, 6 over 40. 12k becomes 12 over 40. And 20k, I can leave this as 20 over 40. Now I have values for x and my probabilities. So let's make some space and I can draw in my table. Let's start with the top row. I have x in my first column. My x values 1, 2, 3, and 4. Now in my second row, I can say the probability that x is equal to x. We know that when x is 1, probability is 2 over 40. So let's put this in over here, 2 over 14. When x is 2, probability is 6 over 40. You can leave your answers in this format. You don't need to simplify. When x is 3, probability is 12 over 40. Let's put this one in here, 12 over 40. And finally, when x is 4, we have 20 over 40. I can put this in as well, 20 over 40. And this is my distribution table. Now I'd like to move on to binomial and geometric distribution. The difference between binomial and geometric distribution is the number of trials. Binomial distribution has a fixed number of trials n, while geometric distribution does not. When working through questions in this section, always determine if you are given a total number of trials. If you are, then it's binomial distribution, but if there is no total, then it's geometric. Let's start with binomial distribution. Information may be given to you in the following format. X is binomially distributed, followed by n and p. N is the total number of trials, and p is the probability the event is happening. Make sure to learn that your brackets include n and p. This is very important for your exam. When working with binomial distribution, we use the formula. Probability that x is equal to r is equal to NCR multiplied by p with an exponent of r multiplied by q with an exponent of n minus r. Here n is the number of trials and r is the restriction. So if you're looking at 3 trials out of 5, then n is 5 and r is 3. P is the probability that an event occurs, and q is the probability that the event does not occur. Q is the complement of P, so the value of Q is 1 minus P. To find the estimated mean, we use the formula mean is equal to NP, so you can simply multiply N and P together. To find the variance, we use the formula NPQ. Remember that the standard deviation is still the square root of the variance. Let's look at an example. The probability that a child can define a prime number is 0.35. Out of a group of 14 children, find the probability that the following number of children know what a prime number is. Let's start with part A, exactly 3. We're working with binomial distribution, so we're going to use the formula probability that x is equal to r is equal to NCR multiplied by p with an exponent of r multiplied by q with an exponent of n minus r. The question tells us that the probability is 0.35. This is our p-value. It's up here. I'm going to say that p is equal to 0.35. Q is our complement. So to find Q, I say 1 minus 0.35, and I see that Q is equal to 0.65. We're working with 14 children, so this is our value for n. So n is 14. In this question, we're looking at exactly 3. So 3 is our value for our restriction r. So r is 3. Now, to find the probability, all I need to do is substitute these values into the formula. So I can say probability that x is equal to 3 is equal to 14c3 multiplied by p, 0.35, with an exponent of 3, multiplied by 0.65, with an exponent of 14 minus 3, which gives me an exponent of 11. Now I can take my calculator. I can say 14c3 multiplied by 0.35 with an exponent of 3 multiplied by 0.65 with an exponent of 11 is equal to 0.1365 and so on. Round off your probability to 3 significant figures and I get an answer of 0.137. Let's look at part B. Find the probability that less than 3 children. If we are working with less than 3 children, we could have no children at all, 1 child, or 2 children. These are the values of R that we need to consider. So I can say probability that X is smaller than 3 is equal to probability that X is 0, 1, and 2. This means that we need to fill 0, 1, and 2 into our R value in our formula for each value of X. So let's start when X is 0. I have NCR, so this becomes 14C0 multiplied by P, 0.35 with an exponent of 0 multiplied by Q, 0.65 with the exponent of N, which is 14, minus 0, which gives me an exponent of 14. But please remember that when working with NCR, if you have an R value of 0, NCR is 1. We also know that if you have a value with an exponent of 0, your answer is 1. So in this case, we have 1 multiplied by 1 multiplied by 0.65 with an exponent of 14. This is the only value I need to consider. So I'm going to say 0.65 with an exponent of 14. I'm going to leave it like this for now. Now let's find the formula when X is 1. So I can say 14C1 multiplied by 0.35 with an exponent of 1 multiplied by 0.65 with an exponent of 14 minus 1, which is 13. Again, when working with NCR, if R is 1, NCR is N. So now we have 14 multiplied by 0.35 with an exponent of 1. We don't need to write down the 1. So it's 0.35 multiplied by 0.65 with an exponent of 13. Now let's substitute 2 into our R value. 14C2 multiplied by 0.35 squared multiplied by 0.65 with an exponent of 14 minus 2, which gives us 12. These are the 3 sets of values that we need to consider. But remember that X could be 0, or X could be 1, or X could be 2. So we need to add these values together. So I'm going to take my calculator and I can say 0.65 with an exponent of 14 plus 14 multiplied by 0.35 multiplied by 0.65 with an exponent of 13 plus NCR 14C2 multiplied by 0.35 squared multiplied by 0.65 with an exponent of 12 is equal to 0.08392 and so on. Round off to 3 significant figures. And as my answer, I have 0.0839. And now we can look at part C. The probability that more than 1 child. We're working with 14 children. If we have more than 1, it could be 2, 3, 4, all the way up to 14. That is too many values that we need to consider. But if we were to calculate the distribution of all 14 values, we would get an answer of 1. So it stands to reason that the probability that x is greater than 1 must be equal to 1 minus the probability that x is smaller than or equal to 1. So I can say that the probability that x is greater than 1 is equal to 1 minus probability that x is smaller than or equal to 1. If x is smaller than or equal to 1, this means that x could be 0 or x could be equal to 1. And we already found values for these in part B. So now I'm going to say probability that x is greater than 1 is equal to 1 minus, let's open a bracket. Let's jump back to part B. If x is 0, we have 0,65 with an exponent of 14. I can put this in here, 0,65 with an exponent of 14 plus x is equal to 1. Let's go back again. We use this value over here. 14 multiplied by 0,35 multiplied by 0,65 with an exponent of 13. And now I can take my calculator. And I can say 0,65 with an exponent of 14 plus 14 multiplied by 0,35 multiplied by 0,65 with an exponent of 13 is equal to 0,0205. Now all I need to do is subtract this from 1. So I can say 1 minus my answer is equal to 0,9794. Round this off, and get an answer of 0,98. Please just remember that this works the other way around as well. So if the question asked us to find probability that x is smaller than 13, we could say 1 minus probability that x is equal to 13 or 14. Please remember this. It is very important and will definitely help you in your exam. Finally, I'd like to move on to geometric distribution. When working with geometric distribution, we only consider P and Q. An event happens or it does not. Geometric distribution is more realistic than binomial. We can use the formula for binomial distribution, but with geometric, it is up to you to decide when to use P and when to use Q. This will depend on the given scenario. When working with a distribution smaller than a given value, we use this formula. Learn this. It is not in your formula sheet, but you will need it in your exam. Please just keep in mind that the symbol in the bracket is smaller than or equal to r. So if x is smaller than 3, then x is smaller than or equal to 2. Always keep this in mind when working with this formula. Also remember that this does not apply to events greater than r. To find the mean of a geometric distribution, we use the formula mean is equal to 1 over p. You will never be asked to find the variance. Let's look at an example. Tanya is learning to play basketball. She knows that the probability that she shoots the ball through the hoop is 1 over 3. Part A says find the probability that Tanya shoots the ball through the hoop on her 5th attempt. Let's find our P and Q values. The probability that she shoots the ball through the hoop is 1 over 3. So P is equal to 1 over 3. The complement is the probability that she does not get the ball through the hoop. So Q has to be equal to 2 over 3. Now, every scenario is realistic. If Tanya shoots the ball through the hoop for the first time on her 5th attempt, that means she does not get the ball in the hoop on her first 4 tries. So there's no ball through the hoop, and no ball again, and no ball on the 3rd try, and no ball on the 4th try. And then she shoots the ball through the hoop on her 5th try. When we have one probability and another, we multiply them together. The probability of not shooting a ball through the hoop is 2 over 3. So say 2 over 3. Multiply by itself 4 times. So let's put this into a bracket with an exponent of 4. Then on the 5th attempt, she does shoot the ball. So we can say multiply this by 1 over 3. Now I can take my calculator, open a bracket, 2 over 3 with an exponent of 4 multiplied by 1 over 3 is equal to 16 over 243. 16 over 243. This is the probability that Tanya gets the ball through the hoop on her 5th attempt. Now let's look at part B. Determine the probability that Tanya gets the ball through the hoop on no more than 3 attempts. No more than 3 attempts, which means that x is smaller than or equal to 3. And we now know that probability that x is smaller than or equal to our restriction, let's say r, is equal to 1 minus q with an exponent of r. In this case, our r value is 3. So we can say the probability that x is smaller than or equal to 3 is equal to 1 minus, from part A, we know that q is 2 over 3. Okay, 2 over 3 with an exponent of r, which is 3. Now I can take my calculator. 1 minus, let's open a bracket, 2 over 3, close the bracket, with an exponent of 3 is equal to 19 over 27. Over 27. And finally, we can move on to part C. Find the estimated mean. To find the estimated mean, you can say the mean is equal to 1 over p. We know that p is 1 over 3, so we get 1 over 3, which leaves us with a mean of 3.